In this lecture we are going to start with other types of two-dimensional plots. So here the first type is polar plots. So MATLAB provides plotting capability with polar coordinates also, which generate a polar plot of angle theta and radian distance r. Let us take an example like x vector having some values from 0 to 2 pi with the step size of pi by 100. Y vector having values sine of x. We are going to plot a polar plot. So for that we are using command polar x comma y. So this will generate a polar plot. We can also add title in the usual way, which we have discussed in our previous lectures. So this is how you can plot a polar plot. Next is logarithmic plots. Let us take an example like x from 0 to 0.5 to 50, y equals to 5 into x raised to power 2. We are using subplot command here. Subplot 2 comma 2 comma 1 plot x comma y. Going to give title as polynomial linear / linear and y label as y, and we are using the grid in our figure window. After that we are going to plot the semi-log x graph. So I just make changes in the previous written statement. It is our 2 comma 2 comma second plot. I have just changed the name here as semi log x. So the semi-log x generates a plot of values of x and y using a logarithmic scale for x and linear scale for y. So I just give the title as polynomial log and linear because x-axis have a logarithmic scale and y-axis has a linear scale. So I have given the title as polynomial log and linear. Next is our third plot, which is semi-log y, which generates a plot of values of x and y using linear scale for x-axis and logarithmic scale for y-axis. So I'm just writing here semi-log x comma y and change the title from polynomial linear and log because y-axis is having a logarithmic scale. Next is, in this case also, I just want to add the X label. I just add the X label here. X label is X so next is our log plot. This will generate a plot of the vectors x and y using logarithmic scale for both x and y. So our fourth figure is log x comma y. This is our fourth figure. And here I have to change the title as polynomial log, because here x and y axes have the logarithmic scale. So now I am going to open the figure window. So this is how the four graphs, or we can say four figures, will be shown. So these are the logarithmic plots. So this is the simple plot having linear x and y axis. So this is our semilog x, this is semilog y, and this is log x. So this is how you can use different commands to draw the logarithmic plots. Our next plot is bar graphs and pie charts. So first of all, I will clear the command window. I'll clear the workspace window also. Now I am going to assign values to x and y vectors as just simple 1, 2, 5, 4, 8. Y equals to having some values x 1 to 5. Next is subplot 2, 2, 1, bar x. So bar x command is used to draw the bar graph. So I'm going to give the title as a bar graph of vector x. So this is the bar graph of vector x. Next is, I'm going to draw the bar graph of vector y. So I just replace the x with y, and this is our second window, and this is the bar graph of vector y. Next is bar h command. So this will generate a horizontal bar graph when x is two-dimensional matrix and bar h groups the data by rows. But when x is vector, bar h generates a horizontal bar graph. So here I am just going to use bar h for x, and this is our third window figure. I just give a horizontal bar graph of vector x. So this is how our three bar graphs are shown. So next is pie command to draw pie chart. So for that, this is my fourth figure, and here I am going to draw the pie chart. So I am using the command pie of x and going to give the title as a pie chart of vector x. So I'm going to open the figure window. So this is our pie chart. So these are the commands which are used to draw or represent bar graphs and pie charts. So next type is histogram. As you all know, histogram is a special type of graph that is particularly useful for the statistical analysis of data. So it is a plot showing the distribution of a set of values. So in MATLAB, the histogram computes the number of values falling into 10 bins. So bins here are categories that are equally spaced between the minimum and maximum values. Let us take an example. We are going to define a matrix X as the set of grades from some final stream of some graduation course. So the scores could be represented in histogram, and which will generated as, just going to give the scores is 95, 74, 87, 22, 78, 34, 35, 93, 88, 86, 42, 55, 48. So I'm just write down the scores in our x vector. Now I'm going to draw the histogram. So I'm just writing the command hist of x. So this is how this will show the statistical analysis of our data. So these are the different types of commands, or we can say different types of plots, or we can say different types of 2D plots. So next is xy graphs with two y-axes. To overlay two xy plots onto the same figure, we are going to use two y-axes. So for example, a graph of sin x and e raised to power x should be drawn by using the commands x, same values, it's from 0 to 2 pi with the step size of pi by 100. Now here y1 is sin of x. Y2 is exponential of x. Now I'm going to plot. So subplot 2, 2, 1. I'm using the command plot x and y1 and x and y2. So this is the plot of x and y1 and x and y2. Next is second diagram. We are going to use the command plot yy. So this plot yy function allows us to generate a graph with two y-axes, one on the left for the first set of ordered pairs and one on the right for the second set of ordered pairs. So this is how our graph is shown, one on the right and one on the left. So on both sides we have the y-axis with different set of values. We can also create a number of different types of plots by adding string with the name of the plot type after the second set of ordered pairs. Like in our third window, here I'm just adding the graph plot yy, and I want to plot semilog x, semilog x of these values. And in fourth graph I'm going to plot the semilog y of x and y1 and x and y2. So this is my fourth window. So this is how the graph will be shown. So next type is function plot. The fplot function allows you to plot a function without defining arrays of corresponding x and y values. For example, fplot sine of x from minus 2 pi to 2 pi. So this will give you the fplot sine of x from minus 2 pi to 2 pi. So this will creates a plot of x versus sine x for x values from minus 2 pi to 2 pi. The MATLAB automatically calculates the spacing of x values to create a smooth curve. So these are the different types of two-dimensional plots. So this is all. Thanks.